A quadratic polynomial is of this form: ax squared plus bx plus c, where a, b, and c are numbers. They're called coefficients. And we're going to first look at some examples of quadratics. All right, for example, let's say I'll just pick some coefficients. Let's say 2x squared minus 3x minus 5. So here the coefficients are 2, minus 3, and negative 5. Okay, so this would be A, B, and this is C. There are some quadratics that we know how to factor, that we can factor. Let's look at those. Let's say we have something like 2x squared minus 10. All right, in this case, the x term is missing, so that means that b is equal to 0. As long as the x squared term appears, as long as a is not equal to 0, we do have a quadratic. So how do we factor 2x squared minus 10? Well, we can just pull out a common factor of 2. That's it. And that would be factored. Or let's look at this example. Let's say we have 9x squared minus 16. Well, this is a difference of two squares, so we can factor this. This is actually 3x squared minus 4 squared, so we can factor this as 3x plus 4. Sorry, 3x plus 4, 3x minus 4. Okay, and one other example, let's say we had something like 10x squared plus 20x. So here, the constant is missing. C is equal to 0. We have the x squared term, we have the x term, but we don't have the constant. And we could just factor this again by pulling out a common factor. This time our common factor is 10x. That's our greatest common factor. Pulling out 10x from 10x squared, we're left with x. And pulling 10x out of the term 20x, and we're left with 2. So here's the factorization. All right, so those are some quadratics we know how to factor. Now these are all two terms. Either we ended up using the difference of two squares formula, or we just pulled out a common factor. But we want to factor things with three terms. So we'll start by doing a product that gives us a quadratic. Right, let's look at this product, a binomial times a binomial. And first we're going to do first times first, that's x squared. And then we'll do our outer and inner products. Here we have 2x, here we have 3x, and these sum to 5x. And then last times last, 3 times 2, that's 6. So we want to reverse this process. So let's look at x squared. Where did x squared come from? Well, it came from multiplying first times first. And where did the 6 come from? Well, that came from multiplying the 3 times the 2. And what about the 5x? Well, the 5x came from the outer plus inner, 3x plus 2x. So as long as we understand where each term came from, then we'll be able to reverse the process. Here we have a quadratic x squared plus 8x plus 15, and we partly factored it. We just left these two blank. Now we know that last times last is last. So that's part of the reverse. If we know the FOIL process, then we know that last times last is last in the result. So if we want to fill in the first blank and the second blank so that the product is 15. Well, how about 5 times 3? All right, well, if we try 5 times 3, that's fine as long as outer plus inner is equal to 8x. Well, if we just check that, here's outer is 5x. sorry, that's inner, and outer is 3x. And 5x plus 3x is 8x, so that's good. We do get 8x. So this is a correct factorization. Now let's look at the second example. Again, last times last is last, so we need to fill in with two numbers whose product is 15. Well, if we try 5 times 3, we know that that won't work because then we'll have the same as we have up here, and outer and inner will be 8x, but we have a 16x here. Well, what other two numbers multiply to 15? Well, another possibility is 15 times 1. Okay, so if we check, we're checking, this is inner, outer is x, and these do sum to 16x. So that's correct because we have 16x over here. So this is the type of reasoning that we're going to do when we factor quadratics, or we do our what we call reverse FOIL method. Okay, number one we actually did in the introduction, but we'll do it again. So if we have a quadratic, we factor using the reverse FOIL process. So I'll call this reverse FOIL. And we know that first times first is first, so the only way to break up x squared would be x times x. We'll fill that in right away. Everything here is positive, so I'm going to fill in 2 plus signs. And we know that last times last is last, so we can fill in with two numbers that multiply to 15, two factors of 15. So let's say 5 times 3 or 15 times 1. And we also know that outer plus inner has to equal to 8x. So if we fill in with 5 times 3, all right, then the first is correct, x squared. The last is correct, 15. But we have to check the 8x. So we always check outer plus inner. 3x, 5x, 8x. Okay, so this is our factorization. You can always check by multiplying out, and you would get this. Okay, here's our second example. X squared plus 8x plus 12. Okay, we'll put down 2 sets of parentheses. Okay, first times first is first, so the only way of breaking up x squared would be x times x. And everything is positive, so I'm putting plus signs in. Now, last times last is 12. We can factor 12 as 4 times 3, or maybe 6 times 2, or 12 times 1. Now we have to get outer plus inner must be equal to 8x. So if we try 4, 3, you see we get 7x. So this is not the correct factorization. All right, so we're going to try 6 times 2. Let's do that one. All right, let's try outer and inner. And we do get 8x. That's what we were looking for our middle term. So this is the correct factorization. Sometimes we have to try more than one, okay, until we get the right factorization. Okay, here we have x squared minus 10x plus 21. Notice the middle coefficient is negative. Again, I'll start by filling in with x times x. And now 21 could be 7 times 3, or maybe 21 times 1. And we want to get minus 10x in the middle. Well, outer plus inner, if I fill in with 3 plus 7 plus 3, I won't get minus 10x in the middle. But then we realize minus 7 times minus 3 is also equal to positive 21. If we have a negative here and a negative here, we could get a positive for the last coefficient that we call c, the c coefficient. So if c is greater than 0, that means our factorization might have 2 plus signs, or it could also have 2 minus signs in the middle, 2 subtractions. In this case, because b is negative, it must be minus minus. All right, let's try this. Here we have minus 7x, and we have minus 3x, and this sums to negative 10x. So this is the correct factorization. So here's our rule. If we have a quadratic of the form ax squared plus bx plus c, and if c is positive, then the factorization is going to be either plus plus or minus minus. That's the only way that we could get a positive value for c. In number 4, we have a coefficient of x squared that's different from 1. All right, let me just rewrite this. 3x squared plus 13x plus 14. All right, we're going to put down our 2 sets of parentheses, starting our reverse FOIL process. First times first is 3x squared. So the only way of factoring 3 is 3 times 1. So we're going to fill in with 3x and x for first times first. Everything is positive, so I'm filling in with 2 pluses. Now, last times less is 14. Well, we can factor 14 as 7 times 2 or 14 times 1. Now, I think if we factor as 14 times 1, our middle term will get too big, so I'm going to go with 7 times 2. And just very lightly, if I put the 7 here and the 2 here, here I'll get 21x plus 2x. Again, it's getting too big. Let me put the 7 here and the 2 here. And let's try to get this middle term. So here we get 6x, here we get 7x, and this sums to 13x. So this is the correct factorization. All right, number 5, we have, I'm just going to put in my parentheses. First times first is 2x squared, so the only way of breaking that up would be 2xx. Everything is positive. Okay, now 15, we can factor that as 15 times 1 or 5 times 3. I think if we filled in with 15 times 1, our middle term would get too big, bigger than 11x. So I'm going to go with 5 times 3. All right, we just have to decide where to put the 5 and where to put the 3. Let's say we start with 5 here and 3 here. We would check outer plus inner, and it's too big. No, that's not correct. So what we're going to do is just reverse. Let's try. I'm going to cross this out. Let's try reversing the 5 and the 3. And we have 5x, and here we have 6x. The sum is 11x. That's the correct middle term, 11x. Okay, so this is the right factorization. All right, now we have a negative coefficient for b, for the middle term, but we still have c positive. All right, so our factorization is going to be either plus plus or minus minus. Because of that negative in the middle, it must be minus minus. All right, so let's fill in our FOIL parentheses with 2 subtraction symbols. Now 3x squared, we're going to break that up as 3xx. And now we need to factor 10. Last times last is 10. We could try 5 times 2 or 10 times 1. All right, let's start with 5 times 2. Let's say if we put the 5 here and the 2 here, I think we'd end up with something more than 13. So I'm going to try the 5 here and the 2 here. And we have minus 5x, and here we have minus 6x. No, that's not it. So I'm going to go to 10 times 1. If I put a 10 here, the product of 10 times 3 is 30. It looks a little big, so I'm going to put the 10 here and the 1 here. And check the middle term. And we do get negative 13x. So that's it. This is the correct factorization. All right, again, put down your parentheses for reverse FOIL. First times first is 5x squared, so break that up into 5xx. And here we have a negative in the middle, so it's either plus plus or minus minus. In this case, it's minus minus because c is positive. Okay, here we have a 6, so we're going to break this up into either 2 times 3 or 6 times 1, and we have to decide where to place them now. We want this 17 in the middle. So let's say we go with 2 times 3. If we put, let's say, the 3 here and the 2 here, and just try that. And we do end up with the minus 17x. If you reversed it, then you would just cross it off and try it the other way around. Okay, so that's our factorization. Number 8, again, c is positive, and the middle term is negative, so it must be negative. Subtract, must be 2 subtraction symbols in the middle. 7x squared we can break up as 7xx. And here we have 6, so that's going to be either 2 times 3 or 6 times 1. We have a rather large middle term in absolute value, so I think I'm going to go with 6 times 1. All right, I see if I put the 6 here, it's going to get too big. 6 times 7, 42, that's too big. And if I put the 6 here, it'll be too small. So I think I'm going to go with 2 times 3. I'm going to put the 3 here and the 2 here, because here I'll get a 21. So I'm getting close to this, so I'm going to go with that. And we do get the right middle term here. And number 9, notice there's one thing a little bit different about this, and that is the 6x squared over here. This can break up, we have different choices, into 3x, 2x, or it could also be 6x, x. So 6 can break up 2 different ways. Before, our coefficient of x squared was a prime number. That is, the only factorization was the number times itself. This one, a little more complicated. Let's say we start with the 3x, 2x. Let's try that. We know our signs are, because since this is positive, our signs are plus, plus, or minus, minus, and since this is negative, it must be minus, minus. So we know about those 2 signs. All right, now here 5, the only way of factoring 5 is 5 times 1. Okay, so let's try. If I put the 5 here, I'm going to get a 15. It's a little big, so let's try 5 times 1 this way. Here we have minus 10x, minus 3x, and that does give us the negative 13x in the middle, which is correct. So this is the correct factorization.